Electron beam welding titanium. Titanium combines excellent corrosion resistance with the highest strength-to-weight ratio of any metal, a combination of properties that make it a great choice for difficult applications in demanding environments, which is why titanium is often called out for aerospace industries. Titanium is optimal for medical uses, such as in artificial joints or implanted devices. It is lightweight, incredibly strong, and compounds within the human body simply don't bond or react with it. As titanium is basically non-reactive to most materials, it does not easily alloy with other metals. It is almost impossible to weld titanium to any other metal. However, titanium is highly reactive with oxygen, which makes it very difficult to weld unless conditions are tightly controlled. When exposed to oxygen, titanium quickly forms a microscopic layer of oxides, and these oxides inhibit reactions with other chemicals, as titanium is heated towards its melting point. The oxides form even faster during welding, which requires melting of the materials to be welded. The oxides form quickly, dissolve, and contaminate the weld pool, the result of which is a weak, low-quality weld. For this reason, titanium is difficult if not impossible to weld in open air, requiring either the use of a cover gas or welding in a vacuum. Electron beam welding is a natural choice for use with materials susceptible to oxidation, such as titanium, because the welding process must occur in a vacuum. An electron beam can provide weld penetration up to 1.540 in titanium, a far deeper weld than any other process can provide. Electron beam welding requires computer control of both the electron beam, the welding environment, and the positioning of the parts for welding, which results in high reliability and easy reproducibility. Titanium parts can generally be welded without submachining as long as they are properly cleaned, and the electron beam welding process can be very cost-effective due to automation, pre-weld cleaning, and decontamination. Before welding titanium, joint areas must be thoroughly cleaned of all oxides and any hydrocarbon contamination in order to guarantee top-quality welds. This can be achieved mechanically by using grinding, filing, scraping, or, most commonly, stainless steel wire brushes to remove oxides. There are also chemical cleaning methods, immersions in caustic solutions and in water, which can be effective. The cleaning method chosen is largely determined by the configuration of the part and the position as of the weld. Hydrocarbon residue on titanium is removed using acetone or an alcohol-based solvent. Chlorinated solvents may form toxic gases when heated and should not be used in and around the welding area. It is preferable that freshly cleaned titanium parts are welded immediately. If this isn't possible, cleaned parts should be stored in airtight plastic bags that are filled with a neutral gas such as argon or nitrogen. During preparation, titanium is a relatively hard metal, and no special machining precautions during fabrication are required. However, there are some common sense guidelines that should be followed. Do not use sharp rags that may be contaminated with oil residue to clean parts. Use clean cloth such as cheesecloth or paper towels. When cleaning titanium surfaces with solvents, precision parts should be handled wearing powder-free latex gloves and cleaned using link-free cotton swabs and delicate touch wipes with the appropriate solvent. If debris must be blown off a part, use a bottled gas such as nitrogen or argon. Compressed sharp air contains moisture and oil residue which can contaminate the weld area. First clean parts and joints using solvents, then clean using a stainless steel wire brush. Wire brushing prior to solvent cleaning typically embeds hydrocarbons and other contaminants into the part, rendering the solvents far less effective. Always use new or recently cleaned stainless steel brushes to clean joint areas. Older, dirty brushes may contain oils and other contaminants. Brushes used to clean titanium should not be used with any other materials as metal. Flakes can be carried on the brush bristles. Generally, Surfaces that have been chemically etched, passivated or precision cleaned should not be wire brushed. Clean all wire brushes and scraping. Filing. Cutting tools frequently. Fixturing. Electron beam welding requires a fairly precise joint in order to maintain permissible gap and mismatch. This is because electron beam welding is a fusion welding process, and filler material is generally not used. Therefore, any space or gaps in the joint will diminish the amount of energy put into the weld, thus negatively impacting the joint. Good weld fixturing is necessary so that the beam can be placed accurately. Electron beam weld types. Butt weld. A fit-up tolerance of 15% of the material thickness is desirable. Shoot edges are acceptable provided they are straight and square. Misalignment and outer flatness of parts should be less than 25% of the material thickness. Lab weld bend through or seam weld. Spaces between pieces to be lab welded severely limit weld penetration and or feed speed. For round welds in titanium, no gap can be tolerated. Fillet weld, square edges and good fit-up are necessary.